Hello, learners. Let me say something uncomfortable. You don't fail permutation and combination because you don't understand it. You fail because you apply the right ideas at the wrong time. Today's video is not about learning permutation and combination. It's about why Cambridge keeps outsmarting you even after you have learned it. Every student I meet tells me the same thing. Sir, I know order matters. Sir, I know NCR, NPR. Sir, I understand this concept. So why do the answers still go wrong? Let me answer this. Because exams don't test knowledge. They test interpretation, they test structure and correction. There are few mistakes which students usually do. Mistake number one, in questions like at least one, look and listen very carefully. At most two, exactly one. Students usually mix cases and start multiplying everything blindly. They start just multiplying everything blindly. Multiplication only works in where and is given, right? Multiplication means and addition means or. When the cases are mutually exclusive, when the cases are mutually exclusive, that means they cannot happen at the same time. For example, breakfast and dinner, they cannot happen at the same time. We add, and whenever they can happen at the same time or must happen at the same time, we multiply. This is mistake number one where most of your answers come wrong. Mistake number two is overcounting the cases without even realizing it. You overcount everything. For example, identical objects. Don't worry, we will practice so many questions in today's class that permutation and combination would never be a problem to you guys again. Groups without order, etc. etc. All right. How can we avoid various other mistakes and how can we just master this permutation and combination so that we can score full marks? This class is all about that. Without wasting much time, let's try to understand this concept by questions and believe me, take a paper and pen, take a notebook and pen, pause the video, attempt the question, then look for the answers. After this class, you will be more confident. It is my promise. All right, let's start. The 40 members of a club include Ranuf and Syed. All 40 members will travel to a concert. 35 members will travel in a coach and other 5 will travel in a car. Ranuf will be in the coach and Syed in the car. In how many ways can the members who will travel in the coach be chosen? See, the word chosen is given over here, right? So we will use combinations over here. We are choosing. There's nothing about arrangement over here, right? Try to interpret first either we are using permutation or combination. We are just choosing. If we are choosing, that means it is about combinations. Yes or no? You want to choose 5 students from a class of 10. All right. Does order matter over here? Does order matter? For example, if you choose Raju, Jaskaran, Avneet, Shipra, Harshit. You have choose these 5 students. Will the order matter if I choose Harshit, Jaskaran, Avneet, Shipra, and R? I forgot the name. Ravi or Raju. All right. Now, order will matter over here or not? No, it will not matter. So we are using combination in the places where order does not matter, arrangement does not matter. Now, think about it. Think with me. How many people are left to be chosen? There were 40 members. 38 are left because 2 are already fixed. We're not talking about them. Out of 38, how many can come in this coach? 1 is already fixed, so 34 can come. Alright, 38C, 34. Yes or no? Think about it. Times it by, why are we multiplying? Because simultaneously they are going in the car as well. How many are remaining over here? Only 4 are remaining because 1 is fixed. Are you thinking with me or not? Alright, 4 is remaining, sir. Now, 4, see how many will remain? 38 minus 4, 4, 4C4. 4C4 is 1 times 38C4. 38C34. That would be 73815. Times it by 1 and you got your answer, learners. Was this easy or not? Yes, you got 3 marks for this question. See, the easiest one. Let us move on to the next one now. Now, look at this one. The 26 members of local sports club include Mr. and Mrs. Khan and their son Abad. The club is holding a party to celebrate Abad's birthday. But there is only room for 20 people to attend. In how many ways can 20 people be chosen from 26 members of the club, given that Mr., Mrs. Khan, and Abad must be included? Alright, we don't have choice for them. These three must be included. How many members were in the club? 26. These three should be included, so 23 choices we have now. Yes or no? Out of that 23, how many members are remaining? 17, because 3 has already been chosen. So 23 C 17, that is 100947. See, in one line we have solved this one. Why Cambridge is giving us so much space? I don't know. Let us move on to the next question, learners. Now this one. Here is where most of the people make mistakes. Let us try to avoid that and score full marks in these types of questions. The bag contains 12 marbles, each of different size. 8 of the marbles are red, 4 of the marbles are blue. How many different selections of 5 marbles contain at least? See, I told you, na? This is where you will make mistake. At least 4 marbles of the same color. Open your mind and start thinking like a mathematician, like Professor X. Think like me. All right. Now listen. First of all, write what you know. We have 4 red marbles because see, we need at least 4 marbles of the same color. So we can have 4 red marbles. Then one will remain, one blue. Okay. Now what we can have? We can have 5 red marbles. Why 5 red, sir? And 0 blue. Think with me. At least 4 means 4 or 5. At least 4. At least. Minimum 4 should be there. So if they are talking about at least, we have to include 4 and 5 as well. So yes, this is also a case. We can have 4 blue and 1 red. Yes or no? Anyone else remaining? We cannot have 5 blue marbles because we have only 4 blue. Yes or no? So let's try to calculate this. 4 red. So out of 8, we need 4. So 8C4 times it by, because they are together, right? We are taking them together. Together they are making 5. So we will multiply over here. Times it by, how many blue were there? 4. So 4C1. From 4, 1. From 8, 4. That gives us 280. Done. 5 red. You tell me what would be 5 red. From 8 we need 5. So 8C5. That would give us 56. Now 4 blue. That is 4C4. Times it by 1 red. 8C1. From 8 we need 1. From 4 we need 4. That would give us 8. Yes or no? Yes. See, these are mutually exclusive events. These cannot happen at the same time, right? Either I can choose this one or this one or this one. Yes or no? So we will add them. If we add 280 plus 56 plus 8, we will have our answer as 344. Very good learners. You got this one also correct. Let us move on to the next one now. A group of six people is to be chosen from four men and 11 women. In how many different ways can a group of six be chosen if it must contain exactly one man? Exactly one man. Can you see this? Exactly one man. We need exactly one man. Now listen. A group of six people is to be chosen. So there would be only one scenario if we have five women and one man. Yes or no? Because we need exactly. See this word exactly. So five women means 11C5 times it by one man means 4C1. Multiply them and you will get your answer. Is it easy or not? Tell me. Tell me. Chosen means selection, right? So we have used combination. Let us move on to the next question now. Two of the 11 women are sisters, that is Jane and Kate. In how many different ways can a group of six be chosen if Jane and Kate cannot both be in the group? Cannot both be in the group. Okay, both should not be in the group, but one can be, right? Okay, so let's see. Only one of Jane and Kate, then neither of Jane and Kate. Jane or Kate. Yes or no? These two cases will be there. Most of you students miss one of these cases. They miss this one. See, they are saying cannot both. So underline these words first. Cannot both. All right. So out of two, only one can be there. So 2C1 times it by. If one has already been included, how many are remaining? See, first of all, separate these two from here. So we will get 9. 2 will be subtracted from 11. Now out of 9, we need 5. So 9C5. Yes or no? Think about it. Very good. But there is a problem over here. There is a problem with this. What is the problem? Can you guess? Yes, you guessed it correctly. Think with me that there were men as well, four men. So there were four men as well. If there were four men, these could be included in the group, right? They are never saying that men should not be included. So this is mistake number two, which students usually do. So what we can write over here is 9 were remaining. 9 plus 4 is 13. And we need 5 out of 13. So 13C5 that equals to 2574. Very good, learners. Now neither of Jane or Kate. This is very simple. We have 13. Neither of them. Neither of them. 13C6. That is 1716. Just add both of them. You will get 2574 plus 1716, that is equals to 4290, and you got your answers. Are you thinking like a mathematician or not? See, go easy on yourself. Till the time you have not practiced 500 questions of permutation and combination, don't reach to a conclusion. Every topic, every topic requires time, demands time. For example, if you want to be a professional table tennis player or a basketball player or a singer as well, you have to give time in the sport, right? Mathematics is the same. You have to give it time. You're not giving it time and then you're saying, I'm not getting it. It's not good. All right? Try to solve maximum questions of this topic, then come to a conclusion. Okay? Now, let us move on to the next one. Find the number of ways in which a committee of six people can be chosen from six men and eight women if it must, see, underline these words. These are the keywords, so underline it. Cambridge won't deduct your marks for underlining. Must include three men and three women. This one is very simple. See, it may seem hard at first, but it is simple. Let me teach you why. We have to we have to find the number of ways in a committee of six people can be chosen. Again, chosen combination. Combination chosen is a favorite word of Cambridge. Whenever chosen is written, first read it again. Cambridge can twist it as well. Most of the time, we will use combination. Most of the time. All right. So we must include three men and three women. Okay. So how many men were there? Six. Out of six, we need three. Out of eight, we need three. And these both are together, right? 3 plus 3 is 6. See? So we have multiplied them. Now, if we multiply them, we will get our answer 1120. See, this much space. Okay? Easy? Not easy. Thinking in the right direction. Nothing is easy. We are thinking in the right direction. Okay, learners? Now, a different committee of six people, a different committee of six people is to be chosen from six men and eight women. All right, we have six men and eight women. Three of the six men are brothers. Okay. The three out of these six men are brothers. Okay, bhai. Three brothers. Write it down. Write it down. Very good. Now, find the number of ways in which this committee can be chosen if there are no restrictions on the number of men and women, but it must include no more than two of the brothers. See, this is the most confusing statement. I'm marking star over here. This is where you lose your marks in Cambridge. Okay? Now listen. But it must include no more than two of the brothers. Out of six men, three brothers are there, and it must not include no more than two of the brothers. So there will be cases no more than two of the brothers. So what cases could be there? No brothers. This is where you get it wrong. No brothers. One brother. Okay? Two brothers. I told you at the beginning of this lecture that interpretation is the main thing that you need in answering permutation and combination. And how will you build it? By doing maximum past paper questions at this time so that you can interpret it easily. And yes, by subscribing to my channel and watching my videos as well. Just joking. Now listen. We have no brothers. So out of three zero brothers we have. So 3C0 times it by different committee of six people has to be chosen, right? So 3 from here, because we have excluded these three brothers. See, 3 plus 8 is 11. So out of 11 we need 6. So 11C6, that is equals to 462. All right, one brother. So 3C1, see, we are taking one brother from here, times it by 11C5, that would give us 1386. Why 11C5, sir? See, one we have already chosen, 5 are remaining. These two add up to 6, and we have to choose 6. That's why we are multiplying it. Now, two brothers. You tell me what should I do in two brothers? 3C2 times it by 11C24. That is 6, right? That will give us 990. Now these are mutually exclusive. These cannot happen at the same time. Can they happen at the same time? No. So we'll add them. Our final answer would be 462 plus 1386 plus 990. That will give us 2838. Very good, learners. You got this one also correct. Let us move on to the next one now. In a music competition, this question is good. Let us try to target this one now. In a music competition, there are 8 pianists, 4 guitarists, 6 violinists. 7 of these musicians will be selected to go to the final. Don't get confused by just reading the question. Don't think it is hard. It is interesting, but it is not hard. Why? If you think into the right direction. How many different selections of seven finalists, one, two, three, four, five, six, seven, can be made if there must be at least two pianists, at least. See, underline this word. Again, interpretation problem. At least, 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 at least two pianists. That means the number could be two or greater than two. Okay, at least means two or greater than two. At least one guitarist. Okay, so guitarist at least, and more violinists than guitarists. Okay, so violinist should be greater than guitarist. Sounds confusing at first, but they have given us two pianists, so I will write P over here. Okay, so P could be 2, 2, 3, or 4. P, P, P. Let's deal with P first because you might find it a little bit complex. So P could be 2, 2, 3, or 4. Right? 2, 3, 4. I can write like that as well. Now, guitarist can be greater than equals to 1. Okay? Because guitarist is linked with violinist as well. So let me check how many guitarists were there. There are four guitarists. Okay, so I'm writing over here one guitarist. Okay, and I will now write how many total we need. We need total seven finalists. So three has already been done. How many are remaining? So four. So four violinists. If I write two guitarists over here, two plus two is four. So three violinists. This equation is satisfied. Is it satisfied or not? Very good. Again, three pianists, one guitarist. How many will remain? 3 plus 1 is 4, so 3 violinists. Okay, very good. Can I write like this? 3 pianists, 2 guitarists. Then only 2 violinists will be there, and this situation will not be satisfied. So I have to exclude this one. Okay, I'm erasing this one now. Are you thinking with me, learners, or not? Very good. Are you thinking like a mathematician? Okay. So now four pianists, one guitarist. Four plus one is five, so two violinists. Any other cases that you can interpret? No, sir, they are not there. So two pianists from eight, so eight C two times it by one guitarist out of four, so four C one times it by four violinists out of six, so 6C4. Then again the same over here. 8C2 times 4C2 times 6C3. 8C3 times 4C1 times 6C3. And 8C4 times 4C1 times 6C2. Get the answer. That would be 1680 and 3360 and 4480 and 4200. Add all of them and you will get your answer as 13720. All right, learners, this was also easy, right? No, it was not easy. We are building our critical thinking. See, whenever you command your brain that this is an easy concept, it shuts down. The subconscious part shuts down. So try to be awake, try to solve it, try to pause the video and solve the question first, then look at the answer. All right, let us move on to the next one. This one now. Richard has three blue candles. Don't worry if you think that these questions I know and I want to just target the hard questions. If you think so, you may fast forward it to the next question. Don't look for the solution of the one which you know without wasting your time. And trust me, we will cover each and every question of this topic in different parts. All right, this is part one. We will try to cover maximum questions over here. I'm making parts because I don't want you to sit for complete hour or 2 hours straight. I want you to just watch part one, explore it, explore the problems, and then if you have doubt, then only come to part two. All right. So Richard has three blue candles, two red candles, and six green candles. The candles are identical apart from their colors. He arranges 11 of them in a line. Arranges. Oh, very good. He arranges them. Sir, he arranges. Sir, so it is permutation, sir. Arrangements means permutation. Find the number of different arrangements of 11 candles if there is a red candle at each end. So we know red is at the each end. 11 minus 2. will give us 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, I have to arrange this 9. That would be different 9 arrangements would be 9 factorial. These are fixed, so we will not include them. Out of these, how many are identical? 3 blue candles. So I will divide it by 3 factorial times it by 6 green candles. So I will divide it by 6 factorial. And my answer would be 84 learners. Identicals we divide, right? Yes or no? Yes or no? Identicals we always divide. So they are saying that find the number of different arrangements of 11 candles if all blue candles are together. All blue candles are together and red candles are not together. See, listen to me. Listen to me very carefully. Now, if we want all blue candles to be together, if we look carefully, how many blue candles were there? 3 blue. So 3 will be together. I take them as one object. After this, exclude the red candles because they are not together. First, we look at the exceptions. So we are keeping the blue candles together. And now we don't want red candles to be together. So exclude red candles first and tell me the remaining objects. How many will be remaining? If I exclude these two, 6 green candles will be remaining. So I will write 6 dash over here. 1, 2, 3, 4, 5, and 6. Yes or no? Treat them as one object. Okay? So one object means we have 6 remaining. Exclude the red. Excluding the red. How many ways this can be arranged? This is one object. 1, 2, 3, 4, 5, 6, and 7. So the answer for this would be 7 factorial divided by 6 factorial. Why are we dividing by 6 factorial? See, the 6 candles are of same color, that is green. G, 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 G. Right? They are identical. So that's why we have to divide by 6 factorial. So if you want to keep something together, treat them as a one object. Now I will shuffle. If I shuffle, how many arrangements can I make if this is one object only? 7 factorial divided by 6 factorial, that will give us 7. Are we done? No, we are not done. Now listen. B, B and B are together. 1, 2, 3, 4, 5, 6 objects are there. Now we want the red candles to be not together. How many red candles are there? There are 2 red candles. Now, how many places where we can place these red candles? We can place it over here. We can place it over here. We can place it over here, 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 and here. Now, imagine with me, we have 2 red candles. For the first red candle to be placed, how many choices are there? There are 1, 2, 3, 4, 5, 6, 7, and 8 choices. So for the first red candle, there are 8 choices. How many for the second one? For the second one, there would be 7 choices because one place would be occupied by the first red candle. Yes or no? Tell me yes or no. Yes, sir, you are correct. This is how we target these type of questions. Now, 7 times 7 is 49 times 8. If we multiply 40 times 8, that is equals to, this would be 8 times 9, that would give us 2. 8 times 4, that would give us 32. And we will have 32 plus 7, that is 392. Is this the final answer? This is where you make your second mistake. See, these red were identical. Yes or no? So I have to divide this by 2 factorial as well. So if I divide 392 by 2, we will get 196 as the final answer. These were identicals, right? These red candles were identical. So we have to divide by 2 factorial. If I divide this by 2, this would be our final answer. Very good learners. Most of the students do the mistake and they write 392 as the answer. They neither divide by 2. So you have to divide it by 2. Okay? Let us move on to the next one now. There are 6 men, 8 women in a book club. The committee of the club consists of 5 of its members. Mr. Len, Mrs. Len are the member of the club. In how many different ways a committee can be selected if exactly one of Mr. Len and Mrs. Len must be on the committee? Exactly one. Repeat after me, exactly one. Okay, very good. Really simple. Out of these two, we need exactly one. So it is 2C1 times it by. How many are remaining if two have been taken away? Total was 14. Two have been taken away, so 12 are remaining. Out of 12, how many do we need? Club consists of 5 of its members, right? So out of 12, one has been selected. We need 4. See, 4 plus 1 is 5 and we need 5. Yes or no? So what will be the answer? 990. Are you visualizing it with me or not? 2C1 means that one time Mr. Land will be there and one time Mrs. Land will be there. They won't be together. Alright, let us proceed to the next question now. In how many different ways can the committee be selected if Mrs. Land must be on the committee and there must be more women? More women. Again, more women than men on the committee. Alright. So, more women than men. How many men are there? There are 6 men, 8 women. Alright, so let me write it down. 6 men, 8 women. Okay? More women than men. And how many people should we select? 5 people. If I take 2 women, it won't work because then there would be 3 men. So I will start with 3 women. 3 women, 2 men. Okay? Then we have 4 women and 1 man. And then we have 5 women. Yes, 0 men. These are the cases. Now listen. Mrs. Len must be on the committee. So we have choices for 2 women over here out of 7. So this would be 7C2 times because one is fixed, right? One is fixed, one is fixed. Mrs. Len should be there. Mrs. Len, Mrs. Len, Mrs. Len. So we have only 2 choices out of 7. 8 women were there, one was Mrs. Len. Okay, times it by 2 men. So 62. We have 3 choices here, so 7C3 times by 6C1. 0 men, so it would be 7C. 4 choices we have over here, so 7C4. All of them are mutually exclusive. This one will come as 315. This one will come as 210. This one will come as 35. Mutually exclusive events add together, and the final answer would be 560. Very good, learners. This was also easy. 4 mark questions you have solved. Clap for yourself. At least clap for yourself. Very good. Let us move on to the next one now. A committee of 6 people is to be chosen from 9 women and 5 men. Find the number of ways in which the 6 people can be chosen if there must be more women than the men on the committee. Okay. More women than men. Same type of question. Let us just skip this one. Or you want me to solve? Let's solve a part. Very simple. Same type of question which we have done earlier. See, the Cambridge is repeating the patterns. Can you see the patterns? So we will do the same thing. 4 women, 2 men, 5 women, 1 man, 6 women, 0 men. Yes or no? So 4 women would be 9C4 times 5C2. Then what should we do over here? 5 women. So 9C5 times 5C1 and 9C6, and we will get the answers 1260630 and 84. And then we will add, and then we will get a final answer. Easy. Okay, let us move on to the next question now. Now let's look at this question. 9 women, 5 men include a sister and a brother. Find the number of ways in which committee can be chosen if sister and brother cannot both be on the committee. Okay, so it includes a sister, that would be a woman, and a brother, that would be a man as well, right? There are various ways of solving this question. You can try a different approach as well. Okay, what I will do is I will take both of them in the committee first, so that would be 2C2, both of them 2C2, times it by the remaining. So remaining would be 8 plus 4. See, I've excluded one sister and one brother, that would be 12. So it would be 12 C4. C4 plus 2 is 6, and the total members in the committee should be 6. It was given 6 people. This will result in 495. Now, see, in these many combinations, brothers and sisters are the part of the committee, 2C2. Now I will take the total ways, repeat after me, total ways in which a committee could be selected. The total ways would be 14, 9 plus 5 is 14, C6, that is 3003. If I subtract these two, will all the possible combinations of brother and sister together be subtracted from the total? And can we find our answer? See, these were the total combinations. In this part, brother and sister both were part of the committee. If I subtract this part from the total, from the universal set, will I get the required combination or not? The same I will do. 3003 minus 495, that would give us 2508. This is the final answer, learners. Got this one also correct. So let's try this one. The next question. A group of 12 people consists of 3 boys, 4 girls, and 5 adults. In how many ways can a team of 5 people be chosen from a group if exactly one adult is included? Exactly one adult is included. Exactly one adult. Okay. So one adult. One adult. We have to choose for 5 people. Okay. Now, it means that from adult we have to choose one. So 5C1 times it by 7C4. That would give us 175. Piece of cake. We got this 2 marks. See, till now, every question that we have targeted, none of them was complex. We are getting 3 marks of these for these type of questions, right? Let us try to target this one now. It may seem tricky, but it is also easy. Think with me now. In how many ways can a team of 5 people be chosen from a group if team includes at least 2 boys and at least 1 girl? At least 2 boys. See again this term, at least. At least 2 boys, 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 at least 2 boys. So at least means 2 could be there. And how many boys are there? 3. So 3 could also be there. At least 1 girl means we have total 4. So 1 could be there. We could have 2. We could have 3. We could have 4. Because 5 people are chosen, right? Yes or no? Yes or no? So how many combinations can we make? So 2 boys, 1 girl. 3 boys, 1 girl. 2 boys, 2 girls. 3 boys, 2 girls. 2 boys, 3 girls. Any other combination that you could make out of 5? Any other combination? Because at least 2 boys should be there. And at least one girl should be there. Okay? So these are the combinations. The only reason you get your marks deducted over here is you neglect any one of these. So, sir, is there any solution that we never neglected? Yes, there is. Let me teach you how. Now, listen. What you can do to avoid this mistake. So, you know that boys could be greater than equals to 2. Girls should be greater than equals to 1. Make their set. Boys could be 2, 3. How many boys are there? 3 boys are there. So, 2 and 3. Now, girls could be 1, 2, 3, 4, and 5. Make a set like this. Listen to me, trust me. Now what we can do is start from here and link it. 2 1, 2 1, 2 2, 2 2, 2 3, 2. Done? Now start from here. 3 1, 3 1, 3 2, 3 2. Can we go 3 3? No. We cannot go 3 3. We cannot go 3 3 learners. What are you doing? Can we go 3 3? We need 5 people. 3 3 will be 6. So that's it. See? 1 2 3 4 5. 1 2 3 4 5. No more outcomes are there. This is the simplest way which I have taught you. Use this way and you will never get it wrong. Alright? Let us try to solve this now. 2 boys, 1 girl. We have 3 members over here. So 1 member will be of adult. Yes or no? 1 member will be of adult. Yes or no? So yes, we can do that. So what we will do over here is we will write 3C2 for boys, total 3 over there, times it by 4C1, times it by 5C2, 2 of adult. Right over here, 3C3 times 4C1 times 1 member more we need. Think with me, 5C1. Over here, 3C2, 4C2, again 5C1. Over here, 3C3, 4C2. This is enough. No more members are required. 3 plus 2 is 5. Over here, 3C2 times 4C3. Again, 5. Answer for this one would be 120, 20, 90, 6, and 12. These all are mutually exclusive learners. Add them, and you will get your final answer as 248. Very good, learners. You got this one also correct. Let us proceed to the C part now. Same group of 12 people stand in a line. So 3 boys, 4 girls, and 5 adults stand in a line. Okay. How many different arrangements are there in which 3 boys stand together and an adult is at each end of the line? So we have adult and adult. How many dashes will be coming in between? There would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now listen. The boys should be together. Boy, boy, boy. I've taught you that take them as one object. B1, B2, B3. Can they arrange it differently? Can B2 come here? Can B3 come here? And can B1 come here? Yes, sir. So we will take them as one object and arrange them. So if we arrange them and take them as one object, so it would be 3 factorial. Treat them as one object and arrange them. It would be 3 factorial. Treat them as one object and arrange them. Would it be 3 factorial or not? Very good. So these are fixed. Don't include them. 1, count with me. 1, 2, 3, 3, 4, 5, 6, 7, and 8. How many different ways we can arrange 8 objects? I have treated this as one object and arranged it because they were unique. So it would be times it by 8 factorial. Yes or no? Yes or no? Now listen. This is the problem with this question. Most of you will do this wrong. Most of you. Why? You will leave it over here. Think with me. Adults were fixed. I know that adults were fixed, but we have to choose from adults, right? How many adults were there? Different adults can come. 5C2, 5C2. Yes or no? We have to choose from these adults. So we will multiply it by 5C2. Or I will give you a simpler explanation so that you don't confuse yourself with C. Listen, over here, how many choices are those do we have? 5 choices. So I will write 5 over here. I will multiply it by 5. Over here, how many choices will we have? 4. So I will multiply it by 4. You can do directly like this as well. Okay. See, we have 5 choices over here. So I multiplied it by 5. 5 adults can come here, right? And we have 4 choices over here. So I multiplied 4 over here. Permutation is all about choices. We multiply the choices. Sir, how do we do by permutation? You have teachers taught us that by permutation we can do it. How can we do by combination? I will teach you that as well. 3 factorial times 8 factorial times it by, we need 2 adults, right? So it would be 5C2. We have selected 2 adults here. Selected. It's like we have called 2 adults, come here. 2 adults have been here, A1 and A2. Now I have to arrange them. One here and one here. Okay, I can place A1 here and A2 here. Or I can place A2 here and A1 here. So I've selected them. Now I can arrange them in 2 factorial ways. This is same as this. Okay, learners? So you will get your final answer as 4, 8, 3, 8, 4, 0, 0. That's all for part 1, learners. Practice the more questions of this topic. See you in part 2 now.